Today we'll study about the suspension and its property. In previous class, we have discussed about solution, concentration, and how to find concentration, and we have also discussed about some numericals. Today, let us see what is suspension. Okay. Suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of medium. We have discussed previously, and I also shown the activity regarding this. Suspension is a mixture that is heterogeneous in nature, means the components are not mixed properly and their composition is not uniform throughout the mixture. Okay, means we can segregate the components. हम उसको अलग अलग देख सकते हैं कि components में solid कहाँ है और solvent कहाँ. Okay, now see the properties. There are four properties of suspension too regarding likewise the solution. First one is suspension is a heterogeneous mixture. We have discussed already that all type of mixtures are categorized in two main categories, that is homogeneous and heterogeneous. So it is heterogeneous in nature. Okay, means the components are not mixed properly. Second, second property. The second properties of suspension is the particles of suspension can be seen by the naked eyes. As I have shown you in the last class, by mixing some soil particle in water, and what we have seen that the soil particles are quite visible in water. Similarly, if you mix some chalk powder in water, that is also visible in water. This is what? This is the particles of suspension which are seen by the naked eye. Okay. Third one, the particles of suspension scatter beam of light passing through it and make its path visible. See, in the case of solution, we have seen the path of light is not visible, but here the path of light is quite visible. The reason is that the particles of suspension are quite bigger in size, so the path of light is visible. See, I have seen shown in the diagram. Here I have taken one solution. Here it is a light source, a torch is there. Here also a torch is there. Okay. So in the case of it is the example of solution. Here, see, if we are blowing a torch at this corner, at this side, the light passes this side, but in the solution, we can see there is no change in the solution. But in the case of suspension, when torch is blown here, see the light crosses this, and this way we can see the path of light. See this dark patch, this patch shows that the path of light is visible. In this case, in the case of solution, the light is not visible. In the solution, the path is not visible, but here the path is visible. It is because the size of particles are quite bigger, and hence they scatter the light. Okay, so the path is visible. So you can say in suspension the scattering is done, but in solution there is no scattering of light. Okay, and this all are due to the size of particle. Okay, the size of particle is responsible for the scattering of light. Now the fourth one is solid particles settle down when our suspension is left undisturbed. That is, suspension is unstable. See, we have already discussed in the previous class that if we take two beaker and put equal amount of water in both, and in one beaker we'll put some sugar, another some soil particle. What you see, if you mix sugar properly and left and keep it on a table undisturbed, what you will see, the sugar particles will not settle down at the bottom of the container. But in the case of suspension, the soil particles settle down. If they are left undisturbed, the soil particles settle down at the bottom of container. This shows what? This shows that suspension is unstable mixture, whereas solution is a stable mixture. The activity regarding this, their stability and the scattering of light. These two activity we have already discussed in the previous uh, session of previous class. Okay, so that's why I'm not showing here the same activity again. Okay, so suspension is unstable and they can be separated from the mixture by the process of filtration. By the process of filtration. By is left here. See, I have shown you here by this diagram. See here in this diagram, it is an example of suspension. Here, see, we can see the hazy picture. Means the water is not so clear. The water is not so clear here. So it is an example of suspension. Now, I will make an arrangement like this. I will take an iron stand. The iron stand, and we've taken one beaker here, one funnel. In the funnel, we will take a filter paper. We'll keep in this process. Now, we'll take this suspension and put it in the funnel with the help of a glass rod, and we'll see that after filtration, the suspended particle remains in this filter paper and the clear water solution is collected in the beaker. So this experiment shows what? This shows that the suspended particles are filtered through the process of filtration, and we can separate the solute from solvent. But this process is not valid for the solution. Okay, so suspension is quite different from solution. Okay, see, it is a heterogeneous mixture, whereas solution is a homogeneous mixture. The particles of suspension can be seen by the naked eyes. It means the size of particles of suspension are quite bigger in nature. Quite bigger in nature. The size of suspension particles are near about 10 to the power 5 nanometer. Okay, so it means it will be 10 to the power 5 minus 5 meter. Okay, or the range is this one, this to 10 to the power minus 7 meter. Means the size of particles is quite bigger as comparison to the solution, because in solution the particle size is 10 to the power minus 9 meter. Okay, so it is bigger in size. Third one is that they can scatter. क्योंकि पार्टिकल साइज बड़ा होता है तो वो पाथ ऑफ लाइट को स्कैटर कर सकते हैं. ठीक है, सिंस द साइज ऑफ पार्टिकल्स आर क्वाइट बिगर as comparison to the solution, so they can scatter the beam of light. See here, scattering is done, means the path is visible. Okay, and in this case the path is not visible. And fourth one, in suspension the mixture is unstable, means if we'll keep it undisturbed on a place the solute particles will settle down at the bottom and it will be separated. Okay, and second one is the particles are separated by the filtration process too. Okay, so that is all about the suspension. In next class we'll talk about collide. Thank you.